Hi, it's Ileana. So today we're going to talk about Earth has received a message laser beamed from 10 million miles away. So I had talked about this a couple of months ago when I wrote the book about the neutrino detector, ice cube neutrino detector array in Antarctica. The fact that neutrinos can send coded messages to submarines, to spaceships, and receive messages, and that the ice cube neutrino array system, which is huge in Antarctica, can do this. It's a huge platform that detects neutrinos, receives them, and decodes where the neutrinos come from in galaxies and what's encoded in them, and that this could be tied to the secret space program in tracking different spaceships, UFOs in Antarctica, that it's a subset of what the ice cube neutrino detector can do. And I'd done remote viewing where that was shown, and I also tracked the science of how that works in theory. Well, this is no longer theory. They can encode information. NASA has demonstrated this, that they can encode information through laser beam technology. They can shoot a laser beam out to the Earth and to satellites, and then also track what is encoded into that laser beam message. And they're planning to use this as future high definition video messages to send from and to Mars without significant delays, and to the moon, farther than to the moon from Earth. So this is done through NASA's Deep Space Optical Communications, DSOC. This experiment and in this environment, so NASA has done this particular experiment with a red laser, and it can also be done with a green and blue laser system. So they've encoded message via laser across a distance of almost 16 million kilometers or 10 million miles. That's about 40 times farther than the moon is from Earth. And they have written about this experiment, that it worked, and it's being infrared light. Engineers can easily transmit its waves in laser form and transmit the information encoded in the laser system waves. So they say it won't get the light moving any faster. So they do say this won't get the light moving any faster, but it does tidy and constrain its beam to a narrow channel. This requires far less power than a scatter of radio waves and is harder to intercept. So right now they're using radio waves to communicate, and they're using satellites. And neutrino detector arrays are much more bigger than laser beam platforms. Laser beam technology is smaller arrays. It's easier to build and easier to work with. So DSOC is the wave, literally the wave of the future, with laser technology to be beaming messages via laser across a distance. Back and forth, video, documents. It's going to expand the World Wide Web across the galaxy. That's what this experiment says, and NASA demonstrated it successfully. This article talks about how it was done, what it's used for. It's the future of communications, moving away from radio wave signals and moving towards laser beam messaging systems. Quantum computing between satellites and lasers, and totally moving to a new type of a system with higher frequencies of light, such as near infrared and increases the bandwidth and therefore a huge boost in data speed. And this upgrades optical communications to the next level of laser beam communications and laser beam messaging via laser, sending information, documentation, technology by laser. So this has been done, and it just proves the long time experiments they've been doing with the ice cube neutrino detector. And like, why do you need a huge array system buried in the ice with close to 5,000 detector systems also buried in pure pristine ice? Because you're testing out neutrino detection software, hardware platforms, and also laser technology. The ice cube neutrino detector, it is in a huge facility. It's buried in the ice, but there's a facility around it. It's not McMurdo, it's a different one, but it is a whole system. It's complicated. There's also genetic experiments there. There's also crash site retrievals of UFOs, extraterrestrial bodies, and much more that I remote viewed and wrote a whole book about it a few months ago. But what NASA has just done with this particular experiment, NASA's Deep Space Optical Communications System, DSOC experiment, it was done successful. Mission accomplished. We're going to have laser communications very soon. It's done. And it's going to be much easier than with neutrino detector arrays. Again, easier to build, much smaller, costs less, and you have high definition video messaging being sent by laser going from Mars infrastructure bases back to Earth and the Moon bases and infrastructures and laboratories. So they want to improve the signaling from Mars without a significant delay. They want to have high definition video messages to and from Mars without a significant delay. Then this is a step towards the tech we need. So they're saying set up good communications between Mars, the Moon, and the Earth. We already have that in the secret space programs. But see, they're disclosing technology they already have via NASA experiments. That this works, and this has worked for a long time. And they're saying successful establishment of the comms link is known as first light. It's not first light. Messages have been sent faster than the speed of light already, but they're finally unveiling this technology for what it is and that it exists, because it has been existing for a while. Finally, we're getting progress that these experiments have worked, and we're going to get beamed messages via laser across the distance between different planets and moons. It already works, but here it is. They're revealing it to us. What's the next infrastructure that's coming that has already existed probably for 50 odd years? But this is it. And it just jives with what my book was talking about, that this stuff has existed in other forms through the ice cube neutrino detector, and that it's a huge hub of communication systems between different spaceships and various infrastructures and structures on Earth and Mars and the Moon. But this is the next wave of laser technology. So it's not going to be done through neutrinos. They're not going to do it through neutrinos. They've already done it through neutrinos. They're going to be doing it through laser technology, which they've also been testing in Antarctica, which was in my remote viewing as well. Various communication systems by neutrinos, by laser beams, different laser beams. And they have laser beam stations in Antarctica as well, several of them. You can see this on maps. If you track laser systems in Antarctica, there are several laser stations in Antarctica that track things of studies and science. But this is the next communication systems by lasers, delivery by lasers, by DSOC. So I wanted to cover this because this is huge disclosure of this tech being revealed and what we can expect from our communications in the near future. This is coming to the World Wide Web near you sometime. And it was done by NASA. Not surprising, of course. It is the forerunner of the new communication system, DSOC, from NASA. I wanted to talk about this because this is important. This is not the first time they've done this. This technology has existed, but it is, this tech has existed in the space programs. Finally, it's unveiled to us, and plans for Mars bases, plans of what NASA is going to be part of, what Earth and the Moon are going to be part of in communication systems with laser beam technology. It's very important what they're disclosing here. And fast data speed being received and huge boost in bandwidth by laser beam technology, sending messages, high definition video and other documents in message systems through laser beam tech. This is the next form of communication and delivery systems of information to be run conjunct with the World Wide Web across the galaxy, not just one planet, across the galaxy. And NASA's the forerunner for this tech. So thank you so much, and this is a great breakthrough to hear this being disclosed and to finally hear the truth for once, some of the truth. It's coming out there.